Hello,
I'll never
hello.
get
Welcome
tired
to
of
the
that song.
stream.
It's so grimy. You're just like all the bass, all the wubs, just no. I guess. I mean, it
Very
was a major
excited to
music
be here.
conference.
Thank you.
Who do we have here today? So we have our friends. Friends, who are you? What are you doing here? Are you coming to talk to us about more starfish or something else on board?
I'm Jaydev, thrilled to have this opportunity to talk about AWS Clean Rooms ML.
And I'm Ryan Lecky. I'm also here to talk about clean rooms, maybe starfish later, but clean rooms first.
Awesome. Well, welcome, Dev. Welcome, Ryan. We're so excited to dive into this topic with you. We're going to be talking about clean rooms and how it works a little bit with machine learning. Is that correct?
Correct.
All right.
And for clarification, in my mind, I think clean rooms, porcelain walls, shower heads, that's not what we're talking about here, right? This is AWS Clean Rooms. What is AWS Clean Rooms?
AWS Clean Rooms helps companies generate ML-based insights in a data collaboration, right? And what do we mean by that? It's essentially a collaboration between two parties where they can run machine learning in a clean room environment without sharing the underlying data, right? It has a ton of applications. What we've started with is a lookalike modeling capability, which is obviously a very familiar paradigm in the world of marketing and advertising. So think of a consumer brand that is looking to find new customers with a media partner, right? So the media partner would have a larger universe of users that the consumer brand is interested in reaching. So for example, recent purchases of products offered by the consumer brand, right? So what we enable is the ability for that brand to provide a seed list of users and find an expanded lookalike audience on the properties of the media publisher, right? And we've also heard from healthcare companies that say, "Hey, wait a minute, there are also really fun applications in the healthcare domain." So, for example, they may find patients who resemble patients who responded favorably to a drug, for example, right? So, if you're a healthcare company running a clinical trial, you may bring a seed list of those patients who went through, responded favorably to that initial phase of the trial, and now you want to find a larger pool for sort of your rollout.
So if Jasmine has billion-dollar marketplace conglomerate and Kyle has this awesome idea for a clothing line, we'll call it Drip Drop, whatever, right? And I want to understand how I can target a broader audience to be in the billions like Jasmine and hang out with her and her crew, right? We'd be able to share each other's data, but without sharing each other's data, it sounds like.
Exactly. So you are not
Yeah,
sharing
I'd go one step beyond sharing. We're not sharing data. We're helping you get insights, get value without having to share data.
Okay,
There's a
there
lot
we
of
go.
privacy concerns around sharing data. Certainly, we're seeing increased regulation, concern from consumers. So, clean rooms is really about figuring out how you get the value, how you get the insight without having to share.
So sharing is not caring in this, but I think you bring up a really good point, Ryan. So I'm not having to give up my secret sauce, and neither is Jasmine. But I'm able to, build insights in a safe and secure way.
Yep, exactly.
Awesome.
So tell us a little bit about how AWS Clean Rooms is helping to address these limitations of, not sharing the data across, but needing to work together. And then, how is it really addressing these challenges and getting folks to productivity?
Yeah, I think
Sure,
we
sure.
have a range of purpose-built privacy safeguards that we offer, right? So I think it's important to note that, let's say there's a scenario where there's a coffee company that's looking to find an expanded audience on a streaming service, for example, right? The data obviously kind of stays only within the respective AWS accounts, right? So in the case of the coffee company, all their seed data kind of stays within their account. And then in the case of the streaming service, all the data that's used to train the model obviously only resides within their account. And there are intuitive controls for users to kind of, as Ryan and Kyle pointed out, without sharing that raw data, really navigate some important business decisions. So one of the things that is really important in the lookalike scenario is understanding how similar your audience is to that seed list that the coffee company provided, for example, right? So it turns out that we can generate those scores for customers to navigate some of those reach and relevance trade-offs in an advertising campaign, and we are able to expose those scores, and some of those intuitive controls really help customers leverage those insights, and without any of that data kind of exchanging hands.
So I see clean rooms machine learning ML, right? And I feel like this is a very popular topic at this time. And pairing it to what clean rooms offers, and I won't try to regurgitate. None that sounds disgusting. I won't try to recap what clean rooms is because I would do it a disservice. I'll let Ryan and Jaidev do that. But why would customers or organizations or just industries want to use machine learning and leverage it, and how could that really just like help out with accomplishing their end goal?
Yeah, great question, Kyle. So I think what we've seen is really scaling to much larger data sets, right? So now Clean Rooms as a service has been around for a while. Clean Rooms ML is a capability that we offer within AWS Clean Rooms. I think what we started off with is a SQL-based approach, right? So what we heard from customers is, as they kind of evolve the size of the data that they're handling, obviously an ML-based approach is much more scalable to data sets with millions, or in some cases, billions of data points, right? I think the other thing to note here is we're able to incorporate with Clean Rooms ML much more sophisticated signals. So for example, unlike some of the traditional lookalike modeling capabilities, where we've done some trailblazing work, is really around understanding and incorporating user behavior, right? So when some of the traditional models look just at attributes, so for example, demographic attributes like zip code to really guide lookalike modeling, we can do much more sophisticated ML-based approaches that look at signals like customers who viewed shows on the streaming service, right? Or in the case of an e-commerce website, we could look at customers who added an item to cart but did not purchase, right? So they turn out to be obviously much more deterministic kind of variables for reaching your best customers versus kind of some of the more conventional variables like demographic targeting with zip code level analysis, right? So I think those are some of the big reasons why customers are telling us that they're seeing a lot of improvements in both model accuracy and also their business results as they use AWS Clean Rooms ML.
Awesome. So we're talking about it, and frankly, I'm more of a visual kind of learner. For me to, certified smooth brain over here, right? So if do you I heard you have a demo that we can see to kind of bundle to this together of what you're talking about when it comes to not sharing data, but being able to collaborate on data to be able to do cool stuff as an outcome.
Yep. Yep, absolutely. We'd be happy to jump into that. So to show data collaboration, I have two AWS accounts here to show both sides of the process, because collaborating with yourself is less interesting. So this first account, let's
I was my own
pretend
best
it's
friend growing up,
Jasmine.
Ryan. So
Don't want to talk about that. So let's take this first account. This is Jasmine's video streaming site. And I have a second account here. This one with the dark background, it can be Kyle's exciting new clothing company. I'm going to start the process of lookalike modeling here in Jasmine's account, where I am going to go and create an ML model. The first part of creating a model is mapping the data I already have in my environment into the format that our ML model expects. Clean Rooms ML is using data stored in S3, cataloged in the Glue data catalog. So if you're used to using a service like Athena or Redshift Spectrum, it's the same data. The first thing I'm going to do is map the columns. So Clean Rooms ML is based on user item interactions. Rather than basing the lookalike modeling, the machine learning on attributes, the innovation, one of the innovations in our service is using these sequence of actions that users take. This makes it easier for users to get going. You don't need a lot of data science expertise. So I select the user ID, I select the item ID. Item is going to depend on the domain of where the data comes from. So Jasmine has a video streaming site, so I'm going to have videos as items. If Jayadev is running a news website on the side, he'd probably be putting things like the news articles here for the item identifiers. Then I select the timestamp, and I can add optional attributes to improve the quality of the model. Here I can select genre. I can select things like ratings that the users give to the videos, and I can select the subscriber tier information about the users. All of this will be considered by the model to try and come up with the most insights possible. Then I give the service permission to access the data. And I'm ready to start the training process. Takes a minute or two to get things set up. So
tiny little hamsters spinning around in a wheel right now to make that happen.
I think it's actually engineers somewhere busy soldering together the wires to get all the everything set up properly. So
maybe a bunch of starfish.
I select here. I have going to do the model training. I select a time window. The goal of this lookalike
let's time out for a second. So you set the data set, but now we went into the lookalike, almost mirror world type configuration here, right?
Yeah. So first step, tell our service how to use the data. Second step, actually use the data to train the model. So the idea is you can use that training data set multiple times. The goal is to find users who might be interested in the fancy new shirts you're selling. To do that, you want to find users who are active on the website, active on Jasmine's streaming platform. So you'll probably retrain this model every week, every 2 weeks, so that you're picking up the new users and the old users are aging out of the system. So to accomplish that, I'm going to pick a time window that's going to depend on how long users stick around on the service. And I kick off the training job. This training process can take anywhere from an hour to up to 2 days, depending on how much data you have. I have 1 million users, it might not take too long. If I have a couple 100 million users, it might take a day or so. Will depend on how much data is involved. Once I once the training job finishes, I'm going to move on to the next step, which is actually starting the collaboration process, bringing the model that I've just built into the clean room.
Okay.
So I have a collaboration. A collaboration is what we call an instance of the clean room. It has, in this case, 2 parties, 2 members, my account and it has the account I'm in here, Jasmine's account, as well as Kyle's account on the other side. So I'm going to go and associate the model that I've created and select this model. And this will fail because I already have it associated, but this is linking my model to the instance of the clean room. This makes it available for the other members of the collaboration to use. Now,
without revealing the data back to one another.
Yep. Without revealing the data, without making the model broadly accessible, you can think of it as being a sort of protected space where only the things each party makes accessible in the clean room, they can only be used inside that clean room.
Okay.
So I'm going to hop over to Kyle's environment, half of this environment, and drill into the collaboration I just set up. So here I can see that model I associated. It's ready to be used. And I'm going to create what we call a lookalike segment. So here I'm going to bring in data from S3. This is going to be the IDs of a set of users who I want to find more users like them. So in Kyle's case, maybe it's users who just purchased a really exciting new line of Star Wars. Sorry, what was that, Kyle?
I said, oh, I'm just discovering that I could have found a lot more friends that are like me using clean rooms back when I was growing up. Where were you 20 years ago, Ryan? So find more people that
don't want to go into those details.
Drip drop.
So you can imagine these are the users who purchased shirts recently. We call these the seed users. At this point, I'll select the model I want to use. So there could be multiple models in this clean room.
Okay.
And I'll create the lookalike segment.
Now, is this just like a one-to-one kind of pairing, or can you do like a one-to-many if you work with other organizations or want to partner with other, industries and such?
Yeah. So these models are reusable. Typically, you're going to have a separate clean room collaboration with each set of partners you're working with. The idea is you want to have really tight control over what data or what ML models you're exposing where. So you definitely,
as a security person, I appreciate that.
Yes, we spent lots and lots and lots and lots and lots of time with security people when we were designing the service, and after we were designing the service, and still to this day, security is job zero for everything we do at AWS, but especially for a privacy-focused data collaboration service. So here I'm going to go and look at the pre-baked model, pre-baked segment. What happens is we're taking each user in Jasmine's data set, and we're scoring it for their similarity to that seed set of users you just brought in. So here it's on a scale of 1 to -1. So I can see that it looks like up to about 5%. The users are pretty similar to that, the seed set of users. And after that, they get pretty unsimilar. So I can use that information to decide how large a set of users I'm going to export. And this list of users will be exported back to Jasmine for her to be
Oh yeah,
able
bring them
to
to me.
go and make them accessible. So Kyle, you would never learn who's in this segment, but rather
Well, I
you could
don't learn
say,
anyway,
Jasmine,
but
here's the segment and here's the fancy ad that I want you to show to these users to get them to come and check out the shirts you have on offer.
wonderful.
So that is the end of the Clean Rooms ML process. Any last questions I can answer?
You know, one of the things that stood out to me when I was reading your What's New post was that this can improve accuracy on lookalike modeling by up to 36%. So not only are customers getting to focus on security being job zero, but they could do it faster and more
Top
accurately.
priority.
I don't know if you know this,
Yes.
but like a little money cannon like rains by like this every time we say security is job zero here at AWS.
Top priority.
Wait, you get paid?
Yeah, in fish and chips and fried starfish. Ugh. Well, Ryan, JDev, it was awesome to have you on. Thank you for talking about machine learning and how robots are not going to take over the world just yet, but how, industries can be able to not share, but be able to collaborate. Did I get that right?
Exactly.
Yes, you did.
Got it. And just one quick question before we kick you off. What language is the machine learning written in?
That's a good question.
As someone that
They
doesn't
don't
know
let
much
me
about
anywhere
machine
near
learning.
that. I don't. I honestly don't know.
Well, we tried. All right, friends. It's great seeing you. Get out of here.